We are then ready to continue, I guess. Tanya?
Can you introduce yourself, Espen? I think you haven't got a chance to do that. It would be nice to know about you.
I can. I just want to know if you are entirely done with your part.
Yeah, yes.
Yes, my name is Espen Tangen. I work at HPC Group, or I work at UIT in the HPC Group there. I'm almost as experienced as Björn. I've been working here since 2008. I am working with, well, I used to work with software. I'm now working with user orientation, outreach, and training. And with me, Bente, you introduced yourself yesterday,
Yes.
but you can redo it if you want.
Yeah, so my name is Bente, and I also work at the HPC group in Tromsø. So me and Espen are colleagues, and I will also be here today to contribute and hopefully have some good questions.
Yeah, and please ask questions. This
Yeah,
part.
so I will be monitoring the hedge talk. So please, any users, if you have questions, I can address them.
Great. This session is somewhat less technical. We'll treat it like a podcast. We'll have some discussions, answer questions. So there will be no exercises. And frankly, you don't need to type along. You can if you want, you don't need to. It's more about understanding. It's more about getting the concept. Fortunately, Dania and Björn actually covered some of the grounds for us, last 15 minutes of their part, but I'll see how far we get. So I'll just start my stopwatch, so I'll have some control over time, of the expenditure of time. In the previous sessions, you have been presented to specifics of HPC clusters and their differences from standard laptops and the benefits and pitfalls of that from a more technical point of view. Now we're going to focus on less technical. Basically, there's responsibility that comes with sharing or access to shared resources. And my favorite picture of this is actually to compare a supercomputer to a large hotel. And you know the difference between a house and a hotel. So a hotel has multiple entrances. You have one or a few reception desks. You have, well, obviously many rooms, and you have many alternatives for moving stuff around inside the hotel, etc., etc. So basically, it's a huge house, but since it's so much larger, it has many alternatives in some places, and some of the solutions are co-organized, meaning that you don't have a kitchen in every room, for instance. Well, you get the concept. And if we view entrances as examples of the login nodes, this has been mentioned to quite a lot of extent already. But if you view the entrance or the login node as an entrance, you must remember that this is shared. It's like jamming the door at a hotel with luggage, for instance. Then you risk that people who are not needing to go to the reception desk, who are not needing to go through the service personnel, still are not able to get to their rooms because, well, the entrance is jammed. So be nice to the entrance. Well, be nice to the login nodes. That's the way of being kind to others. So I just plan to show, I guess I'm now at, I think I am on login 4. Yes, I'm on login 4. Why isn't this working? Damn. Okay. Sorry, I got, yeah, okay. So I just want to see who are on this login node. And you see here, this quite extensive list. A few people I know, a few people I don't know. I see Sabri's here. I see, yeah, a few of my colleagues. I'm here. Yes, there are quite a few people who are logged into this node. And if we want to see what's going on this node, I can either use top, or I can use htop. And you see here, not really much is going on. Very little CPU load. That's a good thing, because that means it's easy to get things done. Here's somebody playing around with MATLAB. Yeah, some processes going on. Message is entrance is shared. So by being kind to the login node, you're also kind and show some consideration to other users. Yeah, I guess quite a few of you have experienced the feeling of standing in line in front of reception when they are really tired after a long travel and want to really just check into the room and get to bed. And the stress feeling when you are forced to be idle and you have no clue for the wait, when the wait will be over. Try not to push that feeling to other users. And when reception is mentioned, sorry, Bente.
No, I just wanted to say, Espen, that I think this is a really great analogy. I think many people have probably experienced the same, being at the hotel. So I just wanted to say it was a great analogy.
Yeah. I kind of like it. Beware that we have more than one login node. For Saga, we have 5. But still, compared to the amount of compute nodes or compute service we have, it's a rather narrow bottleneck. So please be considerate. Yes, but the reception is mentioned. The queuing system is our reception to some sense. And the rooms I like to view as the compute area, the compute servers. And as a general rule, when you attend a hotel, is the private things should take place in the rooms for many obvious reasons. But also note that if you ask for too much resources, you will block others from using those resources. So I just want to show you.
Espen, there is a question here. Is it possible to extend this analogy to interactive jobs?
Yes, it is. Because basically the login nodes are a limited resource. And the more you use it for your things, the less available they are for other things. And really, I mean, I see the point of using the login node for interactive jobs, but then you block the entrance. You offload your baggage. You take a nap in the entrance area. Then you will eventually prevent people from getting into that hotel. So they are not able to, even though they didn't plan to do anything on the login, they are not getting to where they want. You're jamming the doors. So yes, it is. Before I say something more about the compute, I want to just show you, if I find it, yeah. Here, if you search for using shared resources responsibly, you find a standalone web page in our documentation about this. And we have a point about choosing the right amount of memory and how to choose the right amount of cores. This is very well written. I'm not going into details about this, but I advise you to read it through carefully. It's not necessarily trivial, but it's something you should really think about. Because when you submit a job, the first thing you ask for is cores and memory. And as I said, if you ask for too much and not use it, or don't intend to use it, you block that. You block the availability for this resource, or these resources for others. It's a bit like asking for a family room in a hotel when you're really alone and there's a long queue waiting for get a room because all the other hotels are full. It's bad sport. So please, I can also put the links. Could you, Bente, just put the links to these pages in the Markdown document directly?
Sure. I will do.
Great. But also, there is another issue related to these this using or asking for memory in cores, and that is if you submit a job through a job script, beware that what you ask for in the specification area or the order, the queuing system, is not necessarily what you use. I'm going to show you a small example. I have an old cast step run script here. Let's see, yeah, you see it fairly well. Yes. You see here, I ask for 2 nodes and 20 cores on each node. That amounts to 40 CPUs or 40 threads. However, when I submit the job later on, I have to, since I'm running an MPI version of this code, or a parallel version of this code, I have to specify the amount of parallel threads when I submit a job also, or as a command to the program. And I do this down here. And if I was asking for 2 instead of 40 here, it wouldn't matter how considerate I have been for asking for the resources. I would still have asked for a lot more than I was using because I basically forgot. And so a very good, just a tip from the sideline is to, instead of having, sorry, I need to use instead of having 40 as the number down here, reuse this. You see the variable just above it here. So instead of having this line here, I would do this. That will ensure, that will ensure that I get the specification directly from the queuing system. No hurts. That's a good idea. This script you can even inherit, and everything works decently fine. Inheriting scripts is not a good idea, but in this case, it actually wouldn't do much harm. Okay. And yes, there is another issue because what we want you to do, we want you to run production jobs on compute. But there's a potential. I mean, sometimes people are using login for interactive jobs. Sometimes people are running non-interactive jobs on compute, and that is a typical beginner mistake of using a shell command for submitting or executing a script instead of using sbatch. This happens. It's forgivable. It's annoying, but just, yeah, use sbatch when you submit jobs. So use the correct commands for starting jobs and submitting to queue systems. And there is also another level of sharing that applies. That is within the project. That was covered. Some of it was already covered by Dania and Björn, but I want to emphasize it further. Within a given project, you are sharing with your colleagues. You are sharing compute hours, and you are sharing storage space. So if you're using it all, say you have submitted enough hours to cover the whole quota, and your jobs are running in the queue, then nobody else from your project will be able to submit or to run jobs until some of your jobs are finished. Then probably your project leader should apply for more hours, but that's another issue. Storage space is another challenge. If you write directly to your project folder, you may be in a situation where either your jobs or your colleagues' jobs will not be able to finish because they run out of storage space. Suddenly a job dies because the target folder, target area for writing output is full. And that leads us to the question, a question which is also relevant to the last question in the previous session. What file area do you use for running jobs? I want to show you a full table. Yes. By and large, we have three areas, file areas for storage on compute or on the HPC cluster. We have the home area, we have projects area, and we have work. There are a lot of considerations you have to make. You have to view the size, you have to view whether or not it's backed up, you have to view whether or not it's limited, who's owning it, who's got access to it, is it shared, and what are the cleanup procedures. And I've noted here, home is small, it's backed up, it's limited, you own it, only you have access, nobody shares it with you, and you have to clean up. The project area is fairly large. It's backed up. It's limited, but it's large. The project owner owns it, might be you. The project group has access, and it's shared among the group. And this sharing is actually forced. The cleanup is manual. It's done by project group, either a single member or all, or only the project manager. Now you have the work area, which is huge. It's limited by actual amount of disks, but it's quite large. There's no backup. There's no formal limitations, but then again, it's not indefinite. It's owned by you. You're the only one who has access. You share it with no one. But it has an automated cleanup. So if you forget your files for about 3 weeks, they may be gone. They are probably gone.
Espen,
Yes?
when you say that other people have access to my files, so for example, in my project, the project I'm part of, other people have access.
Yes.
What do you mean by that? Can they only read my files, or can they actually edit them, delete them, or what do you put in access?
I'll show you. Okay, I was in, yeah. See here, this is my folder on this shared project, this teaching project. And these are the files I have. So see here, if I want to see what credentials they have, I get this list. These are the these are the file permissions, and everywhere where it says a W, people can edit and delete. So editing is actually deleting. Writing is actually also to delete for some technical or archaic reason. So in this case, this cast-up run script, and if you see here, the first 3 letters indicates the owner, which is me. The second 3, a triple group of letters, indicates the group I'm a member of, and the last 3 letters indicates everyone on the machine. And if you see here now, everyone, all of you, probably all of you listening, can actually delete this file. Darn. I don't really want to. I don't really want that. And actually, that leads to the next natural follow-up question: how do I protect my data? And with protection, I now think about the integrity and not basically restricting the availability to look into it. Our compute systems are defined for what we call green and yellow data, which means public or confidential, but not. I mean, you can't harm anyone if people look into it. It's more like it would be convenient if nobody looked at it. It would be convenient if nobody looked at my research data before I had published the article, for instance. Those are yellow data. But I want to prevent people from being able to delete my cast-up run script. And what then you have seen the change mode command quite frequently. And I want to do, or I want to actually do 7. Sorry. I don't. Oh, it was made by. My bad. It was made by my other user. I'll take one that I own. Yes. You see this, just a small test. I want to change the modularity of that to so that nobody else can delete it. See here? W is gone for the group. Now Bente can't delete my just a small test anymore. Yes, there was a question. There was a question about user groups. It's not straightforward. It's not necessarily a very easy question to reply to, but we use groups as an access limitation for the project folders. All files are automatically shared with the whole group, but nobody from outside can actually. So if you see here, nobody from outside can actually read this or see it. So I can't get into a folder owned by Bente unless I'm in the same project, or Dania for that matter. But as a default, if I am sharing a project with Dania or Bente, I can actually do more or less everything with their files. So that's how we use groups. You can also use groups or you can have a group to invite people to read your files. But groups are defined by administrators and not you. Did that address the question somewhat? So if I just do gid,
Groups.
ID minus G.
Groups.
Groups, of course. Sorry. These are the groups this user is member of. So if somebody wants to share a file with me, they could just add this group to this file to that group, but they also have to be a member of that group, I think, to be able to do that, unless they are administrators or super users. But please correct me if I'm wrong on that.
Probably may I add something, Espen, here?
Please do.
So if someone, the project executive officer or project manager can add users into their project, then automatically they will be added to this group here in the system.
Yes. They will. But change your groups. If you are not in a group where you thought you should be, you or your project manager need to contact Sigma 2 directly. Contact at Sigma 2 NO. Unfortunately, support from NIS can't do that.
The project manager can revoke the access on mass, if I don't remember.
Yeah, they can give and revoke access to projects, but they can't put people in, for instance, the WASP or the Gaussian group.
Oh yeah,
that
yes,
is done
of course.
by the Sigma.
Mm-hmm.
Well, I think I've covered most of the things I wanted to say.
Sven, can we
Yes.
circle a little bit back to the change mode command? Because I think
Okay.
it might be new to some users. And these numbers that you used, could you say something about that?
There's numbers,
So,
yeah.
yeah, I mean like
Sorry.
750 and
Yeah,
what are those
sorry about
numbers?
that. Sorry, the easiest would probably be on this page to use symbols. So what I should have done was instead of 644, I should have been used O. I should have used is it capital G or small g? If I use like this, see, if I want to change the modification of this, or the modularity of this, I do change mod. I can do group plus right and this. See, now it has changed.
So the numbers, that's maybe like a shortcut in a way.
Numbers are a shortcut. It's binary coding of the symbols.
But these numbers, you don't have to remember them. You can Google them, I guess. You can look more
Yes.
into this change mode command, so you don't have to note them now, but because you find it online later as well.
Yes, we can put a link into it. Oh, sorry. The interactive jobs. Well, I missed actually a very vital point. Login. Our login is, sorry. Shit. Do you hear that sound, or I need to turn off my, yeah, sorry, that then sound get went. Sorry, I'm off out of time, but no, the login is for small scale working. It's for editing files. It's for submitting jobs. It's for small tests. And unfortunately, some compilation has to be done on login. But everything else, all production jobs should be done on compute. I mean, should be done on the rooms. And an interactive job in that case would be to hire a room for doing office work, for instance. You're not planned to sleep there, but you need some place to work privately. You can hire a room for a day and work there. I guess that's the best hotel analogy relation to interactive jobs I can give you.
Espen, shall we have a break?
Yeah, just very quickly, take home message. Rule number 1, be efficient. Rule number 2, and by being considered means try to be efficient on login. Try to be efficient when you ask for course or of resources, I mean. And rule number 2, login is for file transfer, editing files, job submissions, short tests, some compilations, small scale compilations. Rule number 3, production jobs should happen on compute. And also be considerate to your team members, but because you are sharing much more with them than with all the other users. Then I'm done.
Yeah. Thank you so much, Espen. Thank you, Bende, for the very nice session. And I would like for us to have a break of 12 minutes, and we can come back around 11:50, and we will have the final session. Radovan and Rafael will join us to give a more info about how to ask help.